This video is part of the mifid RTS2 project. The mifid RTS2 project is trying to suggest that using software models which can be run and seen and understood is a better way of communicating regulatory intent. The project's hosted on GitHub, and you can see here we're at the homepage of the mifid RTS2 project on GitHub, and on that homepage you can see that there are some introductory notes, and they start off by introducing some videos, and this video is going to be one of those that will be linked here. But there are also a list of Jupyter Notebooks, and each one of these is an illustration of how the code can be used. A Jupyter Notebook is a live page. That is, the code on a Jupyter Notebook can be actually executed. We'll start with a walkthrough. And if on the GitHub site you go to that, you can see some text that explains what's going on, but in among the text you can see that there's some code. And you can also see the results. So an in cell is some code, and the out cell is a result of executing that code. On the GitHub website, the view is static. We can't actually run the code. But if we go to my home server and the same page, we can run the code. So this is effectively the same thing, but on here I can put my mouse in that cell and I can run it. And there we see that it's run. Okay. So let's go through these cells and see what they do. The very first notebook we're looking at is basically an overview of what the project is trying to do. So in this first cell, we do the simplest possible example. We import the code and a supporting library. We create a sample trade, put all the details into that sample trade, and then we classify that trade. So here we go, we're creating a classification. Right, now what does that mean? The parts of the regulatory standard which have been implemented as part of the mifid2 RTS project, right, are associated with the RTS2 Annex III taxonomy. And a taxonomy is basically a tree. The point of this particular tree is that it can be used to classify trades. So looking at this picture, if we imagine every marble here is a trade, we drop a marble at the top of the tree, the taxonomy, and the marble will rattle down through here until it ends up in a silo, right, which contains trades which are the same kind of trade. Now here you can just see there's a handful of silos. In the real RTS2 there are hundreds or even thousands of different silos, and the taxonomy can handle processing thousands or millions even of trades. But this is a good illustration for what's going on. So in this example here we've taken a single trade, which is the equivalent of one of the marbles. We've defined the parameters for that, and we've dropped that marble into the tree. So we said the RTS2 Annex III class root classification for our sample trade. This is the thing that we're trying to do here. We want to find out which bucket our sample trade is going to go into. The code has decided which particular bucket that trade will go into, and it's explained it by returning a classification. The last little bit of code in here basically just prints out the classification as a dictionary. So let's have a look at that. So here is a classification. This is a description of one of these areas down here. Okay. So if I want to say, where's this marble here, the one on the right? Where are you? I've got to explain, well, you're in the silo on the extreme right. So let's look at this classification that we produced. We can see it specifies the rules that it's based upon. Basically it's pointing to the document that defines the law, and then all of the things that make up the classification. The asset class, the sub-asset class, and then the various segmentation criterion. Okay, so we've got segmentation criterion 1, which is a currency pair, and segmentation criterion 2, which is a date bucket, which tells us something about how long this particular trade is active economically. Is it going to be a trade that's paying out money for 1 month or 3 months or 6 months? In this case, this trade has dropped into maturity bucket number 2 which is between 1 week and 3 months. So this is a description, if you like, of the trade. And that's what this library really does. Well, here's another way of expressing the same thing. It looks pretty much the same, but this is using something called JSON to express the same thing. The data is the same, it's just presented in a different way. Perhaps this is a better way of doing it. The next cells in this particular Jupyter Notebook start to look at the structure of the tree. And the first thing we do is to print out all the things which are sat at the top of the tree. These are all things called asset classes. So this bit of code here says basically give me the asset class name for every single asset class within the class root. So start at the top and give me all of the things one step down from the very, very top. And these are the things right up at the top. Bonds, interest rate derivatives, and there's a foreign exchange derivative that we saw with our example trade just above. The next level down from asset classes is called a sub-asset class. And if we look at the sub-asset classes for our foreign exchange derivatives, we find we've got these, right? Non-deliverable forward, deliverable forward, non-deliverable, and so on and so forth. Okay, these are all defined in the regulation. And for each one of these, the next level down, something called criterion. Okay, so the criterion for our deliverable FX option is the currency pair and the time to maturity. And that's what we saw in the previous example. This next cell just shows a way of presenting the data that's in the taxonomy. Now on the GitHub website you can see these things in a static way, but on this page we can run this code and make it work. So here these drop downs actually work. So we can go and have a look at our foreign exchange derivatives again. Oops, wrong one. Foreign exchange derivatives. And our DO, deliverable, there he is. Just exactly the thing we saw before. Or we can go into a completely different part of the world and have a look at commodity derivatives and energy commodity swaps. Now you can see here, for this particular sub-asset class, there are 7 criterion. So the number of criterion varies depending upon the sub-asset class you choose. Lastly, we have a quick look at the whole tree. So this cell at the end just says, show me what's in the whole tree. So when we run that, we can see all of the asset classes, sub-asset classes, and criterion all printed out. So now we're going to generate some test data. So we go to another Jupyter Notebook, right? And we'll ask this one to completely restart and clear itself. So we're starting from scratch. And in this case, what we're going to do is, again, get hold of the root of the tree, import a few things, get hold of the root of the tree. There we see the asset class set again, so that's the very root of the tree. And now we're going to actually generate some trades. We're not going to start at the top of the tree with an asset class, we're going to start with a sub-asset class. And this is a very simple case because this particular sub-asset class doesn't have any criteria at all. Okay, so we're going to find the sub-asset class by talking to the root of the tree and asking for the sub-asset class set by name, and find this one here. That's what we're looking for. Okay. Then we ask that sub-asset class, we say, sub-asset class, make some test samples, and the number I want you to make is 1. I want you to make 1 sample trade. Okay. Whenever it returns these sample trades, it always puts them into the list. So here we actually say the sample trades plural is what we're going to get back, but the sample trade is the first one out of that list. Then we take that sample trade and we classify it. We run it back through the same thing that the other trades were run through earlier on, and we print out the result. So let's see what we get. There we go. Once again, the RTS2 version, asset class that are all classified. Very nice. But we can print it out in a different way again by running the next cell, and there's the same classification but printed out using JSON, which looks a little bit clearer. Now what we're going to do is step back up the tree and ask to generate some sample data for an asset class that's further up the tree. So here we say, I'd like to get hold of the asset class, which is this one here, bonds. Then we say, I'd like to generate 1 trade and give me the first one, so the sample is that, and then we classify it and we have a look at the result. The point being made at the end here is that the generation software uses a kind of a randomization algorithm. So you'll notice that the trade flips between being an ETC and an ETN randomly. And the point of the generation is it's going to create a mix of stuff, so we can use that for testing. If you don't want a mix of stuff, you can generate a single trade and set the values to anything you like. So now we're going to look at a slightly more complicated situation. This is a sub-asset class which has got lots of criteria. So here we're going to say get me the sub-asset class by name, which is called the energy commodity swaps, and we know they've got lots of criteria. So now we're going to make a sample one of those, and then we're going to print out the variables that are inside the object which has been created, so we can just see what's been generated. And then when we classify the trade, we can look at the classification of that trade, so it will print that out as well. So if we run this one cell, it will do all those things. Boop, there we go. So the first thing we see here is a Python dictionary that contains all the bits and bobs that have been generated for us. Now a lot of this stuff is not very meaningful. So the notional currency is notional currency value. It's not GBP or USD or anything like that. It's just a string. But there are some things which can be easily generated. So for example, the model knows that to get a maturity bucket, it has to have a from date and a to date, and it's generated sensible values for that. And the model also knows that the energy type can only be certain values. So it's actually put insane values in here. But altogether, when we run it back to the classification, this is what we get. Okay, so this is the full classification. So in this last example, we're going to generate a sample trade for every single sub-asset class that exists in RTS2. And then we're going to pick one at random and we're going to print it out. So just go through the code. First of all, let's have an empty list of samples, so that's ready to take whatever we do. And then we say for every single sub-asset class that we know about, right, which is the root all sub-asset classes, so give me all the sub-asset classes. For each one of those, we take the samples list and we add the sample which is created by the sub-asset class. So here we go, sub-asset class, make a test sample, like one of them, and pop that in here. At the end of this, the samples list contains a sample for every single sub-asset class in RTS2. So having created all of these samples, the next step is to classify them all. This code here is a loop which basically takes every single sample and runs classification for each one, and then all of the classifications end up in this list here called classifications. So the last part is just to print out a couple of examples. So basically we import random, so we can pick random ones out there, and here we just have two things that we pick, random two, and we print them out. So let's see what we get. So sample trade 0 looks like that. Okay, and this one's a C10 derivative, and when we actually classify it, it looks like this. So we are C10 derivative, freight derivatives. We need to know the contract type, freight subtype, so on and so forth. And the other one we had to look at was an equity derivative, and this one's classified as a dividend index future. And there we go. So this Jupyter page just shows us that we can generate arbitrary test trade data from the taxonomy. For organizations trying to understand a regulation, being able to generate test data is a very powerful thing. But going back to the mifid2 RTS project on GitHub, if you've got a moment, please do star the project and watch the project. Thank you very much indeed.